Hi students, this chapter we are going to look at ammonia. Okay, so ammonia formation is a type of reversible reactions. So most of the chemical reactions you have learned so far, like your redox reaction, displacement reaction, acid-alkali, acid-base reaction. These reactions are one directional and they are irreversible. So one directional, you see you use a complete arrow, they go to completion, and completion means salt and water is formed. Okay, some chemical reactions are reversible. Okay, so we usually represent reversible reactions with a reversible arrow. So there's actually two reactions that is occurring. We have the nitrogen gas plus hydrogen gas gives me ammonia, and my ammonia will break down to hydrogen gas and nitrogen gas. So both the forward reaction forming ammonia and the backward reaction, ammonia breaking down, is taking place at the same time. Okay, both forward reaction and backward reactions takes place at the same time. So the reactions do not go to completion. So it doesn't mean that if I have a container, right? If I have a container, and then at the start I have N2 plus H2, right? And then at the end of it, you will get NH3. This one is a complete reaction. Right, reaction goes to completion, but in this reaction, your ammonia formation, this will not take place. The NH3 will break back down into N2 plus hydrogen gas. Okay, at some point of time, reactions will reach an equilibrium. So what do we mean by when the reactions reach equilibrium? At equilibrium, both the forward and backward reactions are still ongoing, okay, but the rate of the forward and the backwards are the same. Meaning to say, if I form two ammonia, at the same time, these two ammonia will also break back down into nitrogen and hydrogen gas. Okay, so the rate of forming and the rate of breaking down is the same. Okay, at equilibrium, there is no change in overall amount of products and reactants. Okay, the amounts of products and reactants in a reversible reaction can be altered by increasing temperature, pressure, use of catalysts. Okay, so sometimes when you increase the temperature, then if it's a gas environment, then the forward reaction will be favored. Okay, because there's one nitrogen, 3 hydrogen, and it only forms 2 ammonia. So this part, at your starting part, there is 3 or 4 compounds, 4 substances or 4 molecules, right? When you increase the pressure, when you make the volume smaller, these 4 will be squeezed even further. So it will be squeezed further and it will form the 2. But if I have the same reaction setup where there's 2 ammonia that's being formed and I go and squeeze these 2 ammonia, it will break back down. But which one is it easier to be squeezed? Is the one with the 4 molecules at your starting site or the one with the 2 molecules of ammonia? Of course, this one will be easier to squeeze, so your forward reaction will be favored. Okay, your forward reaction will be favored, you know, for example, when you increase pressure. Okay, so more about these ideas, right, you will learn it in A level, so don't worry too much about it now.